Okay, I'm going to be off camera a little bit for this one. This is lesson 2.1 and 2.2. Now, different characteristics of data. There's the center of the data. That's the middle of the data set, right? There's what we call variation. This is how much the values in the data vary from each other, or they're spread from one another, okay? So variation is going to become a very important topic that we'll discuss throughout statistics. There's what we call distribution, and that's the shape of the range of the values. It forms a shape, okay? And we're going to talk mostly about the bell curve, but that's called distribution. All right, and we'll discuss more of that here in the near future. There's outliers, which we discussed before, is values that lie far outside the vast majority of the other sample values. So they're either too big or too small for the rest of the values. And then there's time. The characteristic of data is time. Any change in the characteristic of the data over time, because characteristic or things change over time, right? All right, now 2.2, we're going to talk about frequency distribution. First off, frequency is the number of times an event occurs. So if you're doing an observation, for example, and you're looking for how many times someone chooses gum over a candy bar or whatever, every time they choose gum, you'll put a tick mark. Every time they choose a candy bar, you put a tick mark under candy bars. And so you'll tally all those up, and that's what their frequency is. Now, frequency distribution, that's used in a table like the one that you see on the board right now that we have not completed yet. Frequency distribution is just using a table to help us evaluate and identify the information, okay? Now, we have this broken up into different classes. These are categories or intervals, okay? So for example, in this case, my classes are 50 to 69, 70 to 89, 90 to 109, 110 to 129, and so forth. Those are the classes. We have lower classes. These are the smallest numbers that belong to each class. So the lower class here would be 50, 70, 90, 110, and so forth. And then we have upper classes, which are the largest values, which would be 69, 89, 109, 129, and 149. Okay, so those would be the upper and lower classes. We have class boundaries, which is the numbers used to separate the classes. Now the class boundaries is basically, you see how it goes from 69 and then this one starts at 70? The class boundary would be halfway between those. So you'd add 69 plus 70, divide by 2, you'd get 69.5. And here you'd get 89.5 between these two. And this would be 109.5 between those two, and so forth. That's the class boundaries. It's also the class midpoint, which is the middle of the classes. And that's what we did when we added the boundaries and divided by 2. We also have the class width. The class width is this. I'm going to take the smallest value of the next class and subtract the lowest value of the first class. So 70 minus 50 is 20. 90 minus 70 is 20. 110 minus 90 is 20, and so forth. So the class width is 20. It's the width of the interval, okay? Let's talk about why that really works really fast, okay? So everyone see how this is 50 to 69? In normal counting, if I had 50 first, I would start going, I would count to 69 by going 51, 52, 53, 54, right? But we didn't count 50. So this actually is 20 numbers right here, because we normally in counting wouldn't say 50, but 50 needs to be counted, and so there are 20 numbers there, okay? So that's the way that we counter that, and to make it simple, take the smallest number of the next interval and subtract the smallest number, and that tells you the class width. Now we're going to construct a frequency distribution table. We have what's called relative frequency. Now guys, relative frequency and percent frequency, they're basically the same thing. Relative frequency is a ratio of numbers, and percent frequency is the percent of that ratio. And so they're related. Now, the way we find relative frequency is this. We need to add all the frequencies up. When we add these up, we get 78. Okay, so 2 plus 35 plus 35 plus 7 plus 1 is 78. Now to find relative frequency, we're going to create a fraction or a ratio of the data. So there are 2 times that this occurred. We're going to divide that by 78. In our calculator, the way we do that is we hit 2, then the divide sign, and then 78, and hit enter. And that gives us 0.0256. Now guys, we're always going 4 decimal places, 4 numbers behind the decimal. That's because we're going to change it to a percent and we want to have that many numbers in it. Okay? On the next one we would do 33 divided by 78. That's the ratio. 33 divided by 78 gives us 0.4230. Hopefully you guys can see that number. And then 35 over 78 and so forth. I'm just going to write what their values are. This is 0.4487. Oh, yeah. This one's 0.0897. And when you divide 1 by 78, you get 0.0128. So these are your relative frequencies, the decimals. Okay, that's our relative frequencies. This technically wouldn't be written in here because we would have used that to solve it, but this is your relative frequency, the decimal. Now guys, these technically are percentages of the overall value. Let's look at how we find percentage now. Percentage, we move the decimal twice to the right, so this becomes 2.56%. Move the decimal twice to the right, 42.3%. This one's 44.87%. This one is 8.97%. And this one is 1.28%. Now, we can easily take these numbers now and identify things like which one occurs the most often. 44% does, right? So most IQ scores are going to be between 90 and 109. And to take that a step further, over 80% of them are between 70 and 109, right? Because there's 42%, 44%, that's 46%, almost 40, it's pretty much 47% of people that took the test are between these numbers. Which one occurs the least often? Well, only one person here, 1% of people fall within 130 to 149. And so this is a frequency distribution table, and what it does is it helps us identify the different factors of the frequencies of our data. Okay? So relative frequency distribution. Now cumulative frequency, that's a little bit different. And I'm going to have to erase this and start over with the information here. Sorry you had to watch me do this, but let's say cumulative, what that does, we're going to take our IQ score and we're going to change how we're looking at it. We're going to have less than 70. We're going to have less than 90, less than 110, less than 130, and less than 150. That's how we're going to identify our IQ scores now. And cumulative, what that does is it's going to add the previous numbers to the current ones. For example, less than 70, we know the answer is 2. Okay, so that one didn't change any. The first one doesn't change. But this next one, less than 90, that was 33 before. We're going to add 33 and then the previous number 2 to get 35. And then for this one, we're going to add 33, 35, and 2 to now get 70. And then what we're going to do is we're going to add all the previous numbers, and on this next one we'll get 77, and on this last one we'll get 78. That's cumulative frequency. Now again, guys, you wouldn't normally show 33 plus 2 in here, or 33 plus 35 plus 2, or this next one would have been 2 plus 33 plus 35 plus 7, and this one would have been 2 plus 33 plus 35 plus 7 plus 1. You normally don't write that in there with your table, but that's how you solve it, and so that's why I wrote it there, so you guys could see how we come up with our cumulative frequency distribution. That's how often those occur. So 35 of the people, or the respondents, got less than 90, and so forth. Okay? And that's what that does. Now guys, just a quick intro to normal distribution. Normal distribution is a bell-shaped curve, okay? And what its characteristics are: the frequency starts low and it increases to the highest frequency and then decreases to the lowest frequency. And then another characteristic is the distribution is approximately symmetric, meaning each side of the bell curve are almost identical, okay? And we'll talk more about that as we get into the bell curve, just a little bit more discussion on that topic.